Welcome to the Deep Dive, where we take your curiosity and really equip it with key insights from some specific sources.
Hmm.
Today, we're venturing into, well, the pretty intricate world of the Taiwanese IC, this integrated circuit design industry, kind of the brains behind our electronics.
Yeah, absolutely. And to guide us through this, we've got two main pieces of information. One's an excerpt from a document called 048 RST. Seems like some on-the-ground stuff.
Okay.
But our main source is a detailed paper. It's from the Asian Growth Research Institute by Kishimoto Chikashi from back in October 2016. It's called Competitive Strategy and Rise and Fall of Major Companies in the Taiwanese IC Design Industry.
Got it. So our mission today really is to understand how Taiwan got so big in IC design, the strategies their companies used,
Right.
and what made some companies win and others, well, not win. We'll even draw some comparisons with Japan's experience.
Yeah.
Okay, let's dive in. How did Taiwan become this IC design powerhouse?
Well, it really kicked off in the 1990s. And a key thing was this division of labor. Very effective. You had fabulous design houses.
Right, the designers.
Exactly. They just focus on designing the circuits, like maybe an architect designing a building.
Right.
And then you had the dedicated foundries. These are the factories, the manufacturers that actually make the silicon chips, like the construction company building the building.
Oh, okay, so specialization.
Total specialization.
Yeah.
And it let each part get incredibly good, incredibly efficient at what they did.
And this approach, it really put Taiwan on the map globally, didn't it? Not just a small player.
Oh, definitely not. I mean, Taiwan holds the second largest share of the global IC design market now. Only the U.S. is bigger.
Wow.
Yeah, considering they started later than, the U.S., Europe, Japan, it's pretty remarkable.
So what else went into that success? It can't have just been the Fables Foundry split, right?
No, that was crucial. But other things definitely came together.
Yeah.
You had this cluster of companies around the Hsinchu Science Park.
Right, like a Silicon Valley effect.
Kind of, yeah. Lots of innovation, collaboration. Plus, they were physically close to major electronics manufacturers, including the EMS companies.
The assemblers.
Exactly. So a built-in customer base right there. And then you had strong government support policies, money, and a really strong talent pool, lots of engineers, managers, many trained overseas who came back. And we should probably mention ITRI, the Industrial Technology Research Institute.
Okay, what was their role?
Government-backed. Really important for transferring technology, helping the industry get started and grow.
So it sounds like a really fertile ground for this kind of industry. Okay, let's look at the growth itself. How did it actually unfold over time? When did things really start taking off?
Well, if you look at the data from, say, 1996 onwards, you see this general climb in production value for the whole IC industry.
Yeah.
Up till the mid-2000s, then it kind of leveled off a bit, then started rising again around 2010.
But the really explosive growth.
Yeah, the really high growth rates, like over 30% a year, that became much less common after about 2001.
Interesting. And within that, I think you mentioned manufacturing. The foundries were a huge part of that growth.
That's right. The overall industry growth really tracked the manufacturing sector, especially the foundries. Their share within manufacturing just kept climbing.
How much?
Went from maybe 50% in the late 90s to over 70% consistently by the late 2000s. So specialized manufacturing just got more and more important.
Okay, so manufacturing, especially foundries, were key. But what about the design side? How did its piece of the pie change?
Well, it's interesting. Manufacturing's share of the total IC industry actually went down a bit over time, from like 67% in 96 to a low around 46% in 2009, before bouncing back some.
In design.
Design share grew quite a lot. It went from under 12% in 96 up to nearly 31% at its peak in 2009, settled around 26% by 2014. So design definitely became much more significant.
And the growth within the design sector itself, was that just a steady climb?
Oh, not at all. It was really rapid at first. Production values surged, highest growth rates around the year 2000.
And the number of companies.
Exploded. Went from maybe 30 in 87 to 140 by 2000, then jumped again to 250 by 2003. After that, it sort of plateaued.
So a real boom period.
Yeah, but that boom led into what the sources call a new competition era, right around the turn of the millennium.
New competition era. Sounds tougher. What changed?
Well, several things. The cost of designing and making these chips just kept going up. significantly.
Complexity increases cost.
Exactly. And the market got more concentrated. The big guys got bigger, making it harder for new companies.
And the success rate for startups
Plummeted. Seriously, it went from something like 80% in the late 90s to under 10% after 2001.
Wow, that's dramatic.
Yeah. And that led to a lot of mergers and acquisitions starting around then. Companies needed scale, resources.
So consolidation. But did new design companies still manage to pop up?
They did, yeah, but they looked a bit different. They often came from, say, people returning from Silicon Valley with niche expertise.
Yeah.
Or they were spin-offs from bigger companies, even IDMs, the ones who design and manufacture.
Right.
And you also saw investments coming from the set makers, the companies making the final products, and even the foundries.
So less purely entrepreneurial, more strategically backed.
Yeah, exactly. A shift towards these sort of group-backed models.
Yeah.
It reflected that tougher competitive landscape.
Makes sense. The industry was maturing. Okay, so let's shift gears. What were these companies actually designing? What applications were their ICs used in?
Well, between 96 and 2010, information processing was huge. Initially, things for PCs, memory, chipsets.
Yeah, PC boom.
Right. But later it shifted more towards optical drives, LCD monitors as the PC market changed.
Okay, what else?
Consumer electronics became more important too. Moved from simpler stuff like toys towards digital TVs, home appliances.
And communications.
Big growth there too. Driven by the internet, obviously. And then mobile phones really taking off.
And who was buying these chips? Where were the customers?
Geographically, you mean? Well, between 95 and 2010, Taiwan itself and then Hong Kong, China were consistently the biggest markets.
How did that balance shift?
Initially, Taiwan was the main customer base, but its share went down over time while Hong Kong, China grew significantly. By the late 2000s, Hong Kong, China was the largest region.
Why the shift?
Mostly because the big system manufacturers set up their assembly lines in mainland China. So the IC design firms had to deliver chips right there, to support production.
Right, follows the manufacturing footprint.
Yeah.
Okay, we've got the context. Now let's get into the strategies. How did these Taiwanese companies compete so effectively? The first point mentioned is being standard product-oriented, focusing on ASSPs, not ASICs. Can you unpack that?
Sure. So the basic difference. ASICs, application-specific integrated circuits, are custom chips made for one customer, one specific use, like a bespoke suit. Exactly. ASPs, application-specific standard products, are also for specific applications like phones or TVs, but they're designed to be sold to multiple customers. More like off the rack, but for a specific purpose.
Got it. And Taiwan went big on ASSPs.
Hugely. They consistently made up something like 80–90% of Taiwan's IC.
The source mentions Japan focused more on ASICs historically. Why?
Yeah, precisely. Japan's semiconductor firms were often part of big electronics companies, so they mainly made custom chips for their own internal divisions or for other big Japanese manufacturers they worked closely with.
Right, serving the parent company or close partners.
Exactly. And the electronics companies themselves often had strong technical teams that did the initial logic design. But this ASIC focus meant the semiconductor divisions maybe didn't develop strong independent marketing or the skills to define products for a broader market. Their sales were geared towards those established relationships.
So Taiwan, by focusing on ASPs, took a different route. Why was that a better strategy for them?
Well, a few reasons. First, ASSPs let you spread the development cost, which gets really high over many customers and products. That's crucial when costs are rising and product cycles are short.
Makes sense.
Second, think about new electronics markets. Often, they start with custom ASICs for differentiation. But as the market matures, standards emerge. And there's a shift towards standard ASPs that offer good performance cheaper. Taiwanese firms were great at jumping in during that transition.
Capitalizing on standardization.
Right. Plus, because lots of companies use the same ASSP, you get feedback faster, you can refine it quicker, bring costs down faster.
Okay, standard products, ASSPs, were key. The next strategy mentioned is the second mover strategy. Not being first, but following. How did that work?
Yeah, the second mover thing was very common. Instead of pioneering a totally new technology or market, they'd often wait until a dominant design or standard started to emerge, usually set by US, European, or Japanese firms.
And then what?
Then they'd jump in with similar products, but focusing on lower cost, better price, faster time to market, and really good customer support. Basically offering a really compelling alternative once the path was clearer.
So watch the leader, then offer a cheaper, faster version.
Pretty much, yeah. Industry folks in Taiwan basically said that they'd watch the leaders, figure out the winning specs, then optimize for cost, maybe tweak it a bit for, say, the China market. Speed was everything.
But that evolved.
It had to. It became more of a fast second mover strategy. You needed to get the new tech earlier, do more independent design work yourself, just to keep up as product cycles got shorter and shorter.
And is that still working?
It's getting harder. Really short product cycles, big players dominating markets. It makes even that fast second approach more challenging now.
It sounds like they weren't just copycats, though. They must have had strengths that made this second mover thing work. What were their advantages?
Definitely. The sources highlight a few things. Low cost and low prices were huge. That came from the specialization we talked about, the efficient supply chains, skilled workforce.
And didn't they have some stock bonus system?
Yeah, historically, this employee stock bonus system was apparently quite effective at motivating people. Then there was speed and flexibility, quick decisions, fast development, often much faster than, say, more bureaucratic Japanese firms.
All right.
And crucially, really extensive customer support.
Right.
Which leads us to the next point.
Okay, let's talk about that customer collaboration. How did working closely with customers shape their success?
This was incredibly important. Taiwanese fabless firms really prioritized constant, close interaction with their customers, the set makers, the guys building the phones, TVs, whatever.
Daily contact.
Often, yeah. They give them deep insight into where the market was heading, what customers would need next. They built long-term partnerships. And a key person here was the project manager, the PM.
The PM role sounds vital.
It really was. These PMs usually had strong technical backgrounds. They managed the whole project, from defining the product right through to delivery. They were the bridge between R&D and marketing sales. Super important for translating customer needs into actual product specs.
So the PM ensured everyone was on the same page, especially regarding customer needs. How did they balance that closeness with developing standard products, the ASSP? Seems a bit contradictory.
Yeah, it's a good question. They had some smart approaches. One way was to design a high-spec, full-featured chip, then offer cut-down versions for different price points or customer needs.
Okay, tiered offerings.
Right. Or they develop a basic tech platform that could be customized. And sometimes an ASIC made for one key customer would later evolve into an ASSP if the need was broader.
Turning custom work into standard products later.
Exactly. This strong PM function and deep customer engagement seems to be something Japan, maybe, struggled with more defining specs effectively for a broad market, executing quickly.
Okay. Another strategy you mentioned, total solution. Sounds like more than just selling a chip. What's that involve?
Yeah, total solution means providing the IC plus a whole support package. So reference designs?
Blueprints, basically.
Yeah, detailed blueprints showing how to use the chip in a final product. Also, lists of recommended components, sometimes even the software needed to run the chip.
Can you give an example?
MediaTek is the classic example, especially with Chinese mobile phone makers, particularly in the lower end. They provided these incredibly complete packages. It meant manufacturers, even those without huge engineering teams, could get phones to market really fast.
So it dramatically lowered the barrier to entry for the manufacturer.
Exactly. Huge benefits for them.
Right.
Less R&D needed, faster time to market, lower costs overall. Now, the flip side for the IC company is that you need really deep understanding of the whole end product. You need system-level expertise inside your own company.
Right. You're not just designing a component anymore.
Precisely. And this is where the field application engineers, the FAEs, come in. They were crucial.
What did the FAEs do?
They're the tech support guys on the ground. They go to the customer site, help them integrate the chip, solve problems, and really importantly, they gather feedback from the field. What's working, what's not, what's needed next.
And Taiwan was strong on FAEs.
Very strong. Taiwanese fabless firms usually had lots of FAEs, and critically, they were located near the customers, including overseas in places like China. This rapid local support was a big advantage.
Compared to Japan, say.
Yeah, in Japan, often the set maker handled more of the system design internally, so maybe there was less need or less development of that kind of extensive external-facing FAE support from the semiconductor companies themselves. Plus, the whole ecosystem in Taiwan and China, dealers, solution providers, module makers, help support this total solution model.
But the source mentioned this model might be facing challenges. What kind of challenges?
Yeah, a few things are shifting. As everyone starts offering total solutions, it gets harder to stand out just based on that. You need unique core tech, too.
Commoditization.
Kind of.
Yeah.
Also, The customers, like manufacturers in China, are getting more technically savvy themselves. They might need less hand-holding.
Right.
And then there's the business model itself. Usually the reference designs, the software, it's all given away free. You make money selling the chips. Is that sustainable long-term, especially as the support gets more complex? People are starting to wonder if they should charge for software for services.
Interesting point. Okay, let's move to selection and concentration, focusing on specific product areas. How did that help Taiwan?
Right. Specialization was key. As electronics got more diverse, more segmented, trying to do everything was risky. Taiwanese companies tended to focus on a few, often related product areas. Figure 11 in the source shows this clearly for the major players.
So depth over breadth.
Exactly. Let them build deep expertise, get economies of scale and R&D for those areas, build strong relationships in those specific markets.
Unlike the Japanese department store model.
Yeah, the source contrasts it with major Japanese firms that often had these incredibly broad product lines that possibly made them more vulnerable to these focused Taiwanese competitors.
So how did the Taiwanese companies pick which areas to focus on? What was the process?
They looked at several things. Market size, potential profit, obviously, how tough the competition was, could they get the tech needed, or did they have to develop it? Timing was crucial, getting in at the right moment. And again, feedback from customers was really important.
But didn't success breed imitation?
Oh, definitely. The source mentions this dynamic. One company hits it big in a product area, and suddenly lots of other Taiwanese companies pile in, intense competition.
Leading to the one-generation king.
Yeah, that idea. A company might have one huge hit product, but then struggle to follow it up or diversify successfully because the competition heats up so fast.
But things change. The source mentions diversification and so integration more recently.
That's right. The industry isn't static. Looking at more recent data, the top Taiwanese companies have started to diversify more. And the rankings at the very top have become a bit more stable since the mid-2000s. Maybe that means better tech, more successful diversification strategies are making them more resilient.
And the SONSI trend. System on a chip.
Yeah, that's a huge trend, integrating more and more functions onto a single piece of silicon.
What does that mean for the fabless companies?
Well, Sokinas have advantages. Lower cost overall, smaller size, less power, faster speed. Good things. But for the design companies, it means you need a much better system-level design skill.
More complex.
Way more complex. Bigger design teams, more complex project management, and it costs a lot more in R&D. That tends to favor the bigger companies with deeper pockets.
And it involves using IP blocks? Pre-designed pieces?
Heavily reliant on IP, yeah, and sophisticated design tools, EDA tools. These trends diversification, Soki, are also big reasons why we've seen more mergers and acquisitions. Companies buying tech or teams they need.
Okay, we've covered the strategies individually. Now the source pulls it all together in Figure 12, the strategic story for Taiwan. Can you walk us through that diagram? How does it all connect?
Sure. Figure 12 basically shows how all these pieces fit together. It starts with the foundation, that second mover strategy and the vertical split with foundries.
Right.
Those enabled the focus on standard products, ASPS, the strong customer support, the cost effectiveness, and the total solution model.
And the internal factors.
Yeah, it highlights things like the strong PM system, lots of FAEs, speed, flexibility, flatter organizations for quick decisions, and crucial feedback loops customer needs driving R&D.
What about the external environment?
That's shown as enabling factors, too. The rise of IT and electronics in Asia, the growth of the ASSP market itself, booming Asian markets, especially China, and having that great manufacturing infrastructure already in Taiwan.
And the core idea?
The core concept that emerges is supporting set makers, often smaller ones, to get products out quickly and cheaply using these solutions. And the result? Sustained profits, competitive advantage. It's a coherent picture.
It really ties it all together. Then Figure 13 offers the contrast, the strategic failure story for Japanese semiconductor firms. What are the main points there?
Figure 13 paints the opposite picture. It starts with them being part of big electronics firms, focusing internally, having close ties mainly with domestic customers.
Leading to
Those broad department store product lines and the focus on custom ASICs for those specific partners, which in turn made it harder to serve diverse global customers, slower to adopt modular design, less focus on broad marketing or application support for external clients.
And the environment didn't help.
No, the declining competitiveness of the big Japanese electronics firms and a shrinking domestic market added to the pressure. Fundamentally, the source suggests a lack of a clear, independent strategy for competing globally as a semiconductor company.
So comparing the two stories,
Taiwan's story just seems more robust, broader in scope, more sustainable in that changing global market, according to this analysis.
That's a really stark comparison. Okay, the final piece of the source looks at the actual companies in Taiwan, the rise and fall. Who are the big names early on, and how did that change?
Yeah, Table 1 shows the top 10 from 91 to 2014. Early on in the 90s, it was dominated by PC chipset makers. SIS, VIA, Ali, that was the hot market then.
Right.
But then, starting late 90s, MediaTek begins its climb, takes the top spot after 2002, and basically stays there, driven by multimedia, then mobile.
And others emerge.
Yeah, around the early 2000s, you see LCD driver IC companies pop up: Novatech, Himax, as flat screens took off. More joined later. By the late 2000s, the top 5 or 6 positions got pretty stable, suggests the market was maturing a bit.
Was the industry very concentrated? A few big players taking most of the market?
Figure 14 shows that early 90s, very concentrated top 10 had over 90% of revenue.
Wow.
Then it dropped a bit as new companies entered. But after 2004, concentration, especially for the top 5, started rising again. And MediaTek's share, the #1 company, just kept growing, reached 37% by 2014. Clearly dominant.
So just briefly, what happened to those different groups? The PC guys, MediaTek, multimedia, LCD, memory.
Well, the PC chipset firms like SIS, VIA, Ali faded as the PC market changed, and competition, especially from Intel, got fierce. MediaTek, as we said, became the leader by successfully moving into multimedia and mobile.
And the others.
Diversified multimedia firms like SunPlus and Realtek found their niches and sustained growth. The LCD driver guys, Novatech, Himax, Ilatech, rode the wave of the LCD boom, and Phison focused successfully on memory-related chips.
So, a dynamic picture.
Very dynamic. Shows how crucial it was to adapt to market shifts and tech changes.
This has been incredibly illuminating, a real deep dive into Taiwan's IC design world. To wrap it up, what are the absolute key takeaways for you?
I think it really comes down to a powerful mix. Adaptable strategies, moving from second mover to fast second, Then relentless customer focus, the total solutions, the FAE support, and strategic specialization, all happening within a really supportive ecosystem and reacting smartly to global market changes.
A winning formula, it seems. Okay, and a final thought for you, our listener, to chew on. Given how fast technology evolves and with new global competitors always emerging, what future strategic shifts might Taiwan's IC design firms need to make to stay ahead? What pivots are essential now? And maybe more broadly, what lessons can other industries facing their own disruptions learn from Taiwan's journey in IC design? That brings us to the end of this deep dive. Thanks for joining us.